Hello guys, I welcome you for this part 4 video of our development of surfaces. So far we have seen two problems which deals with parallel line development. So the one more type of development is called radial line development. So I'm going to explain a problem on radial line development now, right? So we'll see the problem now. So a regular hexagonal pyramid. So the object is hexagonal pyramid, right? Of side of base 30 mm, so each side is having a length of 30 mm and height of 60 mm. So the total height of pyramid is 60 mm, is resting vertically on its base on HP. So it is placing on HP such that two of the sides of the base are perpendicular to VP. So we'll see what is that. And then it is cut by a plane inclined at 40 degree to HP and perpendicular to VP. So they are going to cut by a plane which is inclined at 45 degree to VP, 40 degree to HP and perpendicular to VP. And again one more constraint for the cutting plane is a cutting plane bisects the axis of the pyramid and obtain the development. So you know what do you mean by bisect. So bisect is dividing into two equal parts. So dividing the line into two equal parts is called bisects. So I will explain the problem now, right? So what is given? A hexagonal pyramid. So this is your hexagonal pyramid. So the bottom face you can see there are six corners here. So these are 6 corners here, right? So this hexagonal pyramid having the side of base 30 mm. So each side is 30 and total height is 60. So now how they are placing the pyramid? So that is very important. So it is resting vertically on its base. So this is the vertical position of the pyramid on HP. So it is placed on HP such that two of the sides of bases, there are 6 sides of bases available. Any of 2 sides is perpendicular to VP. So when I place the object like this, my side 1 and this side 2 will be perpendicular to VP like this. So these 2 sides will be perpendicular to VP. You can see here this 2 sides. I am having the finger on it. These 2 sides will be perpendicular to VP. So I am going to place the object on HP by having this constraint, right? So now for the cutting plane, what is the constraint given? For the cutting plane, the constraint will be, so it is cut by a cut plane. The portion which is shown here is a cutting position, right? So cut plane inclined at 45 degree to HP. So in here in the HP inclination of 45 degree I am going to make a cutting plane. One constraint, that is angle constraint. One more constraint enna appadina, the cutting plane bisects the axis of the pyramid. So this pyramid is having axis at the center line which is having the height of 60 mm. So this cutting plane going to cut it exactly at the center, that is your 30 mm la poi cut panna podu. So it is divided into 2 equal parts, 30 mm for the cutting portion, 30 mm for the remaining half, that is called bisection. So this is how your problem works. So now I am going to explain graphically how we can able to develop the radial development. I told you what we mean by radial development in the initial video. So I am going to make the graphical, then we will do the experimentation. So for this, first I am going to make a simple position now, right? So for the simple position I am going to draw the XY line. So this is your X and Y. So bit extended, right? Then so the portions I told you already, the 2 sides will be perpendicular to your VP, right? So that is how you have to place your object. So I am going to place like this. So this is a hexagonal pyramid, so which is having 6 sides when you are viewing from the top. So just like this. So I'm having a point O at the center. So this is my point O at the center. So it is center now. So I'm going to connect all these points. So I'm going to connect all these points. So that is your slant edges. So these edges are called your slant edges. Right? So I'm going to give a name like this. So this is your O, center, A, B, C, D, and this is your E, and this is your F. Right? So now what I'm going to do now, I'm going to make the projectors from all the points. Right? And it is joining here. So since it is a pyramid, it is going to meet at a point called apex. So you know the apex is at the height of 60 mm. So from point O, I am going to mark at the height of 60 mm. So I am going to make a point, and this is your O dash, which is at the height of 60 mm. So I am going to join all the projected points to the lines like this. So this is one edge, and one more edge will be here. So I just connected the pyramid like this, right? So now give the names for the pyramid. So this is your side A and F. So A dash is visible and F dash is in hidden. So this is your F dash. So I'm giving a name inside. So A dash and F dash within a bracket. So this is a B dash and E dash. So B dash will be visible, E dash will be hidden. So this is C dash, D dash. So C dash will be visible, D dash will be in hidden. Right? So once you know these points, so after knowing these points, I told you in radial development, so for radial kind of development, we need to focus on true length for your development. So we need to find the true length. So since it is in slant edge is parallel to your VP and inclination with respect to HP, you will not get true length. So only when you keep the object, the edge is exactly parallel to your VP, you can able to get the true length. So for that I told you the method in the first class itself. I told you in the first video lecture itself. So you have to draw a horizontal line which is passing through a point O. So from the point O, so you just draw a horizontal line like this. Then O as a center, OA as a radius, I am going to make an arc here. So I am just tilting this edge to parallel to my XY line. So I am just making this line parallel to my XY line. So that's what I am going to do. So with this I am going to draw an arc here. So which is cutting at a point here. I am giving a point name as a M, and I am projecting it to my XY line. Right? So that is my M dash. Right? So this M dash O dash point will be true length of my slant edge. So I'm going to connect like this. So this O dash is meeting at the point M. Right? So this length will be true length of slant edge. So this is your true length of slant edge. So you need to know this true length for your development, right? So before getting into cutting plane, I am going to develop this first. So we will see the development for this regular hexagonal pyramid first. So for that, what I am going to do now, this solid is having 6 equal sides. So for that, I am going to make a point called O. This is your center, right? and I'm going to draw the first edge which is having a length of OA. So OA, this is your exactly, the length will be exactly equals to your true length of your slant edge. So this is your slant edge or a true length. So now take a compass. This is your center as a O and OA as a radius. You take a arc. You draw arc here like this. You draw arc, right? So for a convenient length, you just draw it first, and you know it is having 6 equal sides. So the pyramid is having 6 equal sides, and each side is having 30 mm of size. So you take a compass, 30 mm of side, you take it from the scale, and from the point A you just mark the first point, then second point. Each will be in an equal distance of base size of 30 mm. Right, so now we give the name. So this is your B, C, D, E, F, 1, 2, 3, 4, 5, and again the final point will be A. So you connect all these points with your center point O. So this is your OB, and this is your OC, and this is your OD, and it's keep on going like this. O, E, O, F, and this is your O, F, and finally this is your O, A. So this should be in equal divisions. So equal division I have to divide. So I told you in the first class itself, it is not a curvature. Since your pyramid is having the bottom sides as the straight lines, you have to connect your points with straight lines like this. By using a scale, you connect all the points using a straight line. So this is your development for the pyramid, hexagonal pyramid, without having the cutting plane. So now I am going to draw the cutting plane now. So what is the constraint given for the cutting plane? So the cutting plane constraint is given. So it is at inclination with respect to HP 40 degree. So the inclination will be 40 degree angle, and it's also cut exactly or passing through the bisect point. So first we will mark the bisect point. So total length of your total height will be 60. So this is your 60 mm. Right. So what I am going to do now, I am going to exactly make a cutting plane that is passing through the center. So this is my bisect point of the axis. This is your 30 centimeter, and I am going to draw a line or a cutting plane that is passing through this point like this. It is passing like this. The angle will be 40 degree. So parallel to your base, the angle is 40 degree, the inclination, and it is passing through the bisect point. So this is 30 mm and the above point is 30 mm, right? So we are going to remove this part, and this part will be your remaining part, right? So I told you, so we have to mark the denotions for the cutting plane now, right? So I'm going to have a name like this. So for this I'm going to give names as this edge is your P dash. So P dash, right? And this is your Q dash, R, right? So these are all visible edges. In the other side, you will be having the hidden side. So here you can see. So when you are cutting the point here, right, like this, when you are cutting a point like this, yeah. So this is your P, Q, and R. The other side is also there. So the other side, the name you have to give in the hidden sides, right? So that is your within a bracket S, the other side, P, Q, R, S, P dash, and u dash. The other side will be u dash, right? So now you know the points. These points are, these cutting points are in slant edges of the line, but we have to mark these points in a true shape of your development site. So what you have to do? So you have to draw a horizontal line from this O dash to your true length of your slant edge. So I'm going to draw a horizontal line here, and one more line is here, and one more line from here. So these are all 3 points, and you can point over here, so which is your P1 dash and U1 dash, and this is your Q1 dash and within a bracket T1 dash, and this is your R1 dash and within a bracket S1 dash. So these are all the true lengths of your edge. So now what you are going to do? So take a compass, O dash and P dash. You measure it, which is on the OA dash line. So OA dash line la you make the point. That is your first point P. Right? The second point O dash Q dash, and the true length will be like this, O dash Q dash. You measure it and you place it on OB line. So OB line la it is here. So which is Q. Right? The next one is your R dash, O dash, R dash, which is in slant edge. For making a true length, you have to measure here O dash and R dash. You keep it here and you place it here. So this is your R. And the S edge, S is on same line, OD line la OS, and which is in the same line. So you make a point S here. Right? And the fifth point is your T. That is on OE line. OE line. Mark the point. The true length is at this length, and you paste it here, and which is at here T. Right? Again O. Yeah, just here. Right? On OF, which is here, OF line is here, the point is U1 dash, which is having a length of this side, and you mark the point here, which is U, that is capital U. And finally again it is closing at the point P, which is having the same length here. So you mark all the points and you connect it, you will be getting the shape like this, right? So when you close it, this is your remaining portion, and this portion is your removed portion. Right? So this U dash and P dash will be in same line, and this is your P, Q, R, S, T edges. So you have to take all these points from this true length. That is very important. These are all slant edges. First you mark the points, then you draw the horizontal lines from each points, each cutting points, and you mark all these points, and you take each dimension and you place it on the corresponding lengths. So now what I am going to do, right? So I am going to make a cut. So I am going to make a cut here. So this is your edges. And I'm going to, by using a scissor, I'm going to make a cut. So we will see whether the shape we are getting or not. So what I have done here, so I just make a cut at the angle of 45 degree, and I just remove the top portion like this. So this is your removed portion, and this is your remaining portion. Since we are not talking about this bottom, so I'm going to cut the bottom portions now. So for that I'm going to make a cut over here first, right? So pause it, please pause the video. So I have removed this top portions as I told here. So by using a cutting plane, the angle of 40 degree, I just removed it. And also the bottom portions of this pyramid, hexagonal pyramid also removed. And I'm just going to develop radial, right? So this is your radial development, and the shape is matching. Somehow it's matching your remaining portion, and this portion is your removed portions. So this is your cutting edges, and you can see this is your cutting edges of your hexagonal pyramid, right? So now also what you have to do, the same way what you have done for the hexagonal prism, so we have to draw the sectional, removed section of your pyramid. So this is your removed section that you have to show here. So how you have to remove it? So for that what you have to do, so here P dash and U dash, this point, no, so you have to project it here, which is on the O dash and O F dash line. So this is your O F dash, O A dash line. You project it and you mark the points. This is your, on OA this is P 1 dash, here it is P, small p, and for OF it is U. Similarly for RS, the point RS, you project it here, and you will get 2 points here on OD and OC. So this is your OD and OC line. So on OC it is R. So this is R, and OD it is small s. So this is your small s. Now, so here the problem you can see, Q dash and T dash point is on same line. So it is on same line. You can easily mark that point. Same line, how to mark it? For that what you have to do? So you have to measure the true length, because this is the true length of the object, which is not slanting. Slant easier true length in the slant edge. So that what you have to do? You have to measure this length in the center point, bisect point Q dash point measure panni, other O dash paste panna, that is your point OB la. What is that? Q dash, Q. Ane mari ide portion you just using a compass, you just place it on the top also, and that is your point T. So this is your Q. So you connect all these points. So when you connect it, you will be getting a shape like this, and you just shade it. So this is the removed portion of your pyramid. So angle in the cut panna removed portion. So that is your the portion. So exactly it is matches. The shape is exactly matches to your removed portion. So this is how we have to deal with radial line development problem. So I just concluded. So far we have seen a parallel line development on hexagonal prism and parallel line development on a cylinder, and we have seen development of surfaces which is dealing with radial line development on hexagonal pyramid. So the assignments is on based on these 3 shapes. So you have done already 3 shapes by using the projection of solids assignments, so which is in the category of prism, pyramid and solids of revolution. So the same way I have done the problems here. So with the shapes that you have with you, so you have to do the assignments. The assignments will be posted in the portal soon. Thank you.